Tiga. Assalamualaikum and hi everyone. Hope you guys are safe and doing well. Sofiah is here. This video is made to fulfill the assignment of subject Remote Sensing and GIS, and here are my details. So before we go to our main topic, I would like to share with you guys the beautiful flyers made by Dr. Hassanazhari just to assign us with this task. Ta-da! So, as you might notice, the topic given is about case study in the application of remote sensing and GIS. A little introduction of remote sensing and GIS. Remote sensing can be defined as the art and science of acquiring images of the Earth's surface without actually being in contact with it. Instead, it uses sensors attached on a platform such as satellites from a certain height to collect data of the Earth's surface in the form of images. For example, images that we see in Google Maps is using remote sensing technology. Meanwhile, GIS is a tool for mapping and analyzing features on Earth. GIS is rooted in the science of geography, and it can integrate common database operations such as query and statistical analysis with maps. It's a very dynamic tool that can link databases to create layers of information into visualizations using maps or 3D scenes. So basically, any digital maps that we see today are actually a GIS map. So if you want to know more about remote sensing and GIS, feel free to click the link in the description box below to hear lectures from Dr. Hassanazhari about the subject. And don't forget to subscribe to Dr. Hassanazhari's channel, okay? Anyway, I decided to go for this paper entitled Predicting Potential Rastrelliger kanagurta fish habitat using MODIS satellite and GIS modeling, a case study of exclusive economic zone Malaysia. The paper was prepared by Hassanazhari and Mustafa for the Science Malaysia Journal of the National University of Malaysia (UKM) and was published 2 years ago in 2018. The two objectives of the study were, first, to investigate the relationship between our kanagurta fishing ground with environmental factors, and second, to determine its fishing ground using suitability index model and generalized additive model. As for your information, our kanagurta is an Indian mackerel or ikan kembung as we call it in Malay. Firstly, the location of the study area is the exclusive economic zone Malaysia, particularly in the east coast of Peninsular Malaysia. It is located in the southwestern part of the South China Sea that harbor high diversity of fish and attract the fishing activity in the EEZ. Geographical information of the study area extend between 1 degree to 8 degree north latitude and 102 degree to 106 degree east longitude. The EEZ is highly influenced by the East Asian monsoon system that played by the three seasonal monsoon wind, which are: first, the southwest monsoon occurring from May to September; second, the northeast monsoon occurring from November to March; and third, the intermonsoon occurring in April and October, and it happened annually. The environmental factors studied in this paper are chlorophyll A concentration and the sea surface temperature SST. Surface chlorophyll A is considered as an index of biological production, which often related to fish production. Meanwhile, SST has also been used for decades by fishermen and researchers to determine fish habitat and fish sustainability. That is why chlorophyll A and SST are used in the study to understand the relationship between physical characteristics with habitat suitability of our kanagurta. Secondly, this research data included analysis of fisheries data, image processing, modeling, and mapping of potential fish habitats. The data of both parameters were taken by the MODIS satellite imagery, derived from NASA GSFC's Distributed Active Archive Center. The daily MODIS Level 1 1 km data of chlorophyll A and SST were successfully obtained. The satellite imagery of the study area was downloaded and processed to Level 3 using CWIFS data analysis CDI 7.4 and address imaging of 2011. Then, the data was projected to cylindrical projection using ArcGIS. On top of that, The fisheries data of R. kanagurta used in this study was provided by the Marine Fishery Resources Development and Management Department. These data were then used to calculate the catch per unit effort (CPUE), which is an index that reflects fish abundance and accounts for changes in the fishing activity. The paper also mentioned previous studies that uses remote sensing and GIS in determination of R. kanagurta distribution, where they applied a density analysis, suitability index, or a simple regression approach. Apparently, this study also integrate the use of habitat suitability index and GAM model, which is a more robust statistical method for modeling and mapping of the data. So this is the overview of the research approach. Next, we go to the results of the study. The graph of average CPUE for R. kanagurta in 2008 and 2009 from January to December was plotted. So this is the graph that depicts the average CPUE in the year of 2008 and 2009. We can see a high catch of R. kanagurta happened in October, while moderate catch observed in May, July, and August, while the rest of the months depict a low catch only. Then, the suitability index analyzed the preferred range of SST and chlorophyll A concentration. The highest frequency of CPUE for SST was at 28.8 to 29.45 degrees Celsius, while the highest CPUE frequency for chlorophyll A concentration was at 0.2 to 0.3 mg per cubic meter. Similarly, the GAM model also analyzed the R. kanagurta catch against chlorophyll A concentration and SST. From the analysis, the significant relationship convergence of chlorophyll A was obtained at 0.2 to 0.3 mg per cubic meter and SST at 29 to 30 degrees Celsius. Finally, the scores of SST and chlorophyll A derived from the suitability index model were classified in GIS to produce a simple prediction map of R. kanagurta. The colored areas on the map were the predicted CPUE values or the estimated fish abundance. Meanwhile, the polygon shapes were plotted on the map as the actual fish catch, in which each polygon shape represents a range of the actual fish catch data. For example, the map dated on 16 February 2009 showed a high potential fishing zones where the predicted catches were above 185 times 10 powered by negative 6 kg per cubic meter at the northern area of the EEZ from the red colored areas. Meanwhile, the area near the coast was green colored, indicating predicted catch between 75 to 90 times 10 powered by negative 6 kg per cubic meter, and it coincides with the actual fish catch data, which was below 100 times 10 powered by negative 6 kg per cubic meter from the circles and triangle plots. The reliability of the suitability index model prediction indicated 75% accuracy with kappa statistics of 0.7. Likewise, a similar map of potential fishing ground of R. kanagurta was plotted using the GAM model. For example, from the map dated on 7 October 2008, height distribution of R. kanagurta was obtained at the northern and center part of EEZ as indicated by the red colored areas. Meanwhile, the actual catch represented by the square and triangle plots, which were between 101 to 150 times 10 powered by negative 6 kg per cubic meter, coincides with the predicted catch at 100 times 10 powered by negative 6 kg per cubic meter as indicated by the green colored areas. The reliability of the GAM model prediction indicated 87.6% accuracy with kappa statistics of 0.8. If you notice, there were 4 maps that were plotted on 4 different dates throughout the year from both models. So actually, the dates represent each monsoon season of the year. Firstly, during the northeast monsoon season, which extended from November to March, distribution of R. kanagurta was observed at the northern waters and along the coast. During this season, high precipitation causes the temperature and salinity recorded were lower. This influenced the formation of water stratification that prevent nutrient mixing from deeper water. So, as a result, high concentration of chlorophyll A was available at the surface and attract the presence of fish. Second, during the intermonsoon that occurred in April and October, high distribution of R. kanagurta was observed near the coastal area. During this season, the current direction of movement influenced by the weakened surface wind direction, allowing a large sea surface heating that results with stratification development. So, areas of relatively stable temperature and high chlorophyll A concentration may attract feeding pelagic species. And thirdly, during the southwest monsoon, which extended from May to September, distribution of R. kanagurta was found near to the coastal area of Peninsula Malaysia, with high distribution scattered in the northern area of the EEZ to the Gulf of Thailand. During this season, strong southwest monsoon wind induced occurrence of coastal upwelling along the east coast of Peninsula Malaysia, bringing about the nutrient-rich deep water to the surface. Thus, it supports plankton growth and provides food to the fish. Conclusion from the study suggested that both suitability index model and GAM model were able to predict potential fishing grounds of R. kanagurta. However, GAM analysis gave a higher prediction accuracy compared to the SI model. Okay, now that we've got to the end of the video, I thank you all for listening and till we meet again in the future, inshallah. Bye!